So today's video is about reflecting points over the x-axis or the y-axis. So let's start with what is a reflection. A reflection is a flipped image, like when you look at yourself in the mirror. So basically, if you're looking in the mirror, you see a flipped image of yourself so that you can actually see your own face. Well, a word that we can use for reflection is the word flipped. And you can think of the FL in reflection with the FL in flipped. And so when you see the word reflect in a math problem, we're just going to simply replace it with the word flip. So points and figures can be reflected or flipped on the coordinate plane. And a point or figure can either be reflected over the x-axis or it can be reflected over the y-axis. So let's look at how you reflect something across the x-axis. So right now we have point A, and point A is located at 4, 3. So it's 4 in the x and 3 in the y. And we want to know if if A is reflected across the x-axis, where would the new point be on the graph? Well, right now we have to first locate, well, where is the x-axis? Well, that is the line that is going horizontal. So this is our x-axis. So that means we want point A to flip over or across the axis. That means right now it's above the x-axis. If it flips over it or flips across it, it's going to land below it. And we want it to be the same distance away. So right now it's 3 away from the x-axis, but it's 3 above. So then when we reflect it, we want it to be 3 below. So the new point is going to be the same distance from the x-axis, just on the opposite side. So if you look at this point here, our new point A, the coordinates are 4 in the x, but now it's -3 in the y. So now let's look at how to reflect something across the y-axis. So the y-axis is the axis that goes up and down. So that means we want our point to flip to the other side of the y-axis. So we want to flip across it. So right now it's to the left of the y-axis. When we reflect it, we want it to land on the right side of the y-axis. Right now point A is located at -2, +3. So when it reflects and flips, we want it to land on this side of the y-axis. So when it lands over here, it's going to be at +2, +3. So again, the new point is the same distance from the y-axis. So right now, point A was 2 to the left of the y-axis, and our new point A is now 2 to the right of the y-axis. So let's do an example. So we want to reflect point B across the x-axis. So the first thing we want to do is locate where is point B at. So right now we see that point is -4, +1. And so the coordinates would be -4, 1. So now we want point B to be reflected across the x-axis. So we want it to flip across the x-axis. So that means right now it's above the x-axis. We want point B, when we reflect it, to land below the x-axis. So we have to look and see, well, how far away is it from the x-axis? Well, it's 1 above. So when reflected, it's going to land 1 below. So this is going to be our new point B. So our new point B will be located at -4, -1. So the original point B was at -4, +1, and then the new point B is now at -4, -1. So now let's look at how we can reflect point C across the y-axis. So if we notice right now we have point C, and it's located at 3, 0. So it's 0, it's 3 in the x, and then it doesn't go up or down at all. So it's 0 in the y. So point C is at 3, 0. We want point C to reflect or flip over or across the y-axis. So right now it's 3 to the right of the y-axis. So when it reflects, we want it to be 3 to the left of the y-axis. So in order for it to be 3 to the left of the y-axis, that means our new point C has got to land at -3, 0. So again, the original point C was 3 to the right of the y-axis, and then when we reflected it, now it's 3 to the left of the y-axis. So just keep in mind that a word that you can use for reflection is the word flip. And if you're flipping something across the y-axis, you want the new point to be the same distance from the y-axis, just on the other side. And if you're flipping something across the x-axis, you want the new point to be the same distance away from the x-axis, just on the opposite side.